Good morning and welcome to a very special episode of the Angry Astronaut. We are joined today by Matt Kuhns of the Masten Space Corporation, or Space Technologies rather. He is the Vice President of Research and Development, and the best way that I could describe this individual from what I've read about him is he is a jack of all trades and a master of all of them. He holds 5 patents, the title of NASA NIAC Fellow. He's also worked on liquid oxygen and methane propulsion systems, which a lot of you are familiar with, all the way to commercial aircraft fuel systems. So a very wide background as far as aerospace technology is concerned. Plus, he's also a published photographer in National Geographic. Quite a varied background. So we are honored to have you on the program, sir.
Thank you very much. Very excited to be here. I really enjoy your work.
Thanks. So the first question that I would have is, the overall mission. Your CEO talks about tearing down the barriers to space. Accessibility to space is something that a lot of folks talk about. What is Masten's plan to tear down those barriers, especially when it comes to lunar missions?
Sure. Yeah, Sean has spoken a lot about that, and David founded the company trying to get to space sustainably and affordably. And the way Masten does that is we use a combination of tried and true engineering along with breaking ground and approaching some of these problems in different factors to do it more affordably and to do it faster and to try to bring early test to increase reliability. So you'll see that represented and manifested in a lot of our different projects and our flying vehicles. Some portions of them are incredibly complex and cutting edge, and other portions of them we build from places like McMaster Carr because there's equipment that we can use off the shelf and get it flying immediately. So it's by combining the old and the new to help us move faster and do things that other people didn't think were possible is what we're focusing on, to remove those barriers and increase that access to space and now the moon.
Well, speaking of the moon, when we're talking about, the advantages of going back there, I would say there's a very large percentage of, the population of the United States, let alone the world, that has no idea that we are going back to the moon. So can you briefly explain, why go back? What sort of advantages is it going to bring to human civilization?
Good question, and definitely we want to help people understand why this is important. There's all of this, the science reasons, of course. The first time we went to the moon, the samples we brought back and the geology that they discovered really changed the way that we thought about the solar system, how it formed, the history of the Earth, understanding our place in the universe. It probably rewrote more textbooks than I can count. So from a science perspective, it's incredibly important with our new understanding of the solar system and all the 50 years of research that we've done in the intermedium to go back and look again and see what else we can learn about our universe. And closer to home, it's important to remember that every dollar of space investment gets spent here on Earth. So it all goes to creating jobs and technologies and capabilities which push us forward as a civilization and humanity as a whole. And you see that spread throughout the world and out throughout the ecosystem. NASA calls them spin-off technologies, and we even see that here at Masten. Some of the rocket technologies that we've developed are now being used in things like automotive, braking systems for cars, medical implants. There's a whole range of areas of technology that benefit from space research because it pushes the boundaries of what's possible. Then after you figure out how to do it in space, you can bring it back to Earth and make everything better here.
Thanks. Yeah, I feel very much the same way, as I'm sure a lot of my viewers do. So, well, all of them, I would say. As far as resources on the moon are concerned, that's something I kind of wanted to get laser focused on. You have a very interesting rover in the works right now, designed specifically to mine lunar ice. Can you give us an explanation of that? What makes it different than other concepts of mining ice on the moon? And also perhaps other resources we might be able to mine there.
Definitely. The Rocket M project for rocket mining is really exciting, and that's a partnership between us here at Masten, Honeybee Robotics, and Lunar Outpost. And we're all contributing some very interesting and compelling technologies and merging them into a package, which creates a system which we think gives us an edge over some of the more traditional mining concepts. So Masten Space Systems is providing the rocket excavation portion of this, and it uses a rocket engine to excavate down and transport regolith. We're using the Honeybee work in Planet Vac and some of their other technologies like PVEX. They're really, really good at building these pneumatic mechanical systems for space, and they've got hardware all over the solar system. And then Lunar Outpost is providing the rover chassis, and it's kind of an evolution out of their current MAP rover, which is headed to the moon. So with the three of us working together, it's really an interesting solution, which we hope solves some of these very challenging problems of how do you mine the moon economically, because it's very, very, very tough work. And if you look at mining here on Earth, you'll see it's big, heavy machinery, which is not what you want to launch to the moon because you can't afford it. And then it tends to be, even though it's big and robust, it does tend to break a lot because mining is very, very demanding. Rock is hard, it's abrasive, it's a challenging environment. So we built this method from the ground up, trying to sidestep some of those restrictions by learning what we can from mining here on Earth and then applying it to the moon. So we took a lot of insights and input from deep sea mining here on Earth.
And as far as this rover is concerned, it is very large. So this is not something that's going to be involved in your 2023 mission. It's going to be, when do you estimate you might be sending this rover to the moon?
That is a good question, and that's very funding related, so I'm going to kind of avoid giving you a date for now. But as soon as we get funding, we can go and start building prototypes and launching them to the moon.
Now, one of your fields of specialty is the methane and liquid oxygen propulsion. And one of the challenges, from my understanding of the moon, is the fact that there doesn't seem to be a whole lot of methane there, or indeed a lot of carbon, to where we might be able to manufacture methane using these Sabatier method, or Sabatier, however you pronounce it. So, how do we meet that challenge? Because everybody seems to be moving towards this kind of methalox type of propulsion. How do we manufacture this in space?
That is an excellent question, and that's a difficult challenge I don't think we've solved yet. Methalox has a bunch of advantages as two cryogens of similar temperature. It makes the propulsion and fluid systems much easier to design in tandem. So that's why we're using it on our new vehicles here at Masten. On the rocket mining solution, I went with a oxygen-hydrogen engine approach, simply for the fact that as we're mining water, we can use electrolysis to split that into its constituents and then continue to run the engine. So that's one of the benefits of the system is for a very low, relatively low landed mass, you can go and bootstrap yourself up. So you don't have to spend a lot of money sending fuel there. You can go with a couple kilograms of oxygen and hydrogen, and then through the mining operation, you can basically bootstrap yourself to run indefinitely.
All right, thank you. And what about the recent discovery that NASA made that there appears to be water ice sort of spread across the lunar surface, but in very small concentrations? Do you see any way that that can be exploited, or do you think that we pretty much need to stick to Shackleton Crater and other shaded areas of the moon where there's a lot of water ice?
Sure, yeah, it's very interesting data, and that's one of the reasons we need to go back and get some ground truth on it, see if there's other places like lava tubes where we could get high concentrations of water at mid-latitudes. I think for the near term on this system, we want to go where you have close access to sunlight, but then also as rich water deposits as possible. The richer your ore body, the easier it is to mine economically. And so that's really going to be the keystone for these early missions. We don't want to spend $1 billion setting up a very complex mining operation on the moon. We want to spend significantly less than that and figure out how to make this into a sustainable business. And from there, you can grow into that larger, long-term, self-sufficient business case.
Thank you. One of my supporters has pointed out that the materials necessary to build solar panels are extremely abundant on the moon, and given the fact that, of course, with 1/6 lunar, with 1/6 Earth gravity, the delta V to transport solar panels into Earth orbit is substantially less than what it would take to launch a solar array from Earth. Do you see that as being an exploitable resource?
I think that there is a lot of exploitable minerals and resources inside the lunar regolith, whether that's oxygen or silicon or aluminum. There's a lot we can go and get. Processing it is going to be the real challenge. The aquafactorum method, which was invented by Dr. Philip Metzger from UCF. He had a NIAC on it last year. It's an incredibly versatile tool, and it has its basis in some of the ways that we do mining, like sorting out the constituents of mining here on Earth, and doing and in factories for bulk powder manufacturing. So we can do a lot to separate out the minerals and the metals based on their magnetic and mass. However, turning the raw product into a usable item, that's a separate challenge unto itself, and I think there's definitely some automation and complexity challenges in doing it on the lunar surface that haven't been solved yet.
Thank you. Another, well, not exactly this actually is a question from one of my supporters. They mentioned that you guys, of course, and you say this on your website, you haven't done any missions in space as of yet, but you have done some simulated landings here on Earth. Can you explain the technology that you've been using for that, the altitudes that you've been landing from, and that sort of thing, the kind of simulated landings on the moon that you've been able to accomplish thus far?
Definitely. So landing here terrestrially as a pathway to landing in space has been one of the core tenets of Masten over the last decade plus. It started with David winning the NASA Centennial Northrop Grumman Lunar Lander Challenge back in 2009 with the Zombie vehicle. And since then, we've flown and landed more than 600 times with 5 different vehicles. The team is actually out flying Zodiac today, and we continue to use that as a pathfinder and development for the systems, the software, the team operations, and kind of the methodologies of how to land repeatably and reliably, and how to get it to work here so we can make it work better on the moon. And that's things like doing multiple tests in one day. I think our record is 5 tests in one day. And we did with Honeybee Robotics and PlanetVac, we did a hopping mission several years ago where we took off, landed, took a sample, and then took back off again immediately and returned to base without any human intervention. So operations like that show us how to do it, which lets us do it better on the moon and have a greater chance of success.
Thank you. Kind of connected to what you just commented on. This comes from Jerry Collins, another one of my supporters. Assuming that you can mine valuable minerals on the moon, where would be the best place to process them? And also, how would you get them to consumer goods manufacturers?
Sure. So for the first question, where do you go and find and process minerals on the moon? Process them as close to the mining sites as possible, and you're going to want a lot of sunlight. So somewhere that gets an abundance of sunlight for power. A lot of these processing techniques, particularly things like aluminum, take a very large amount of power. So to do that, you want to use the sun, or ship in a nuclear. And then from there, where do you go and sell them and market? I think the near term, probably for the next 50 years, the market is going to be all in space. So if you sell water, you're going to sell it to people who use it in space, either for life support or propulsion purposes. And if you sell minerals and other resources, you're going to want to sell them to people who are going to use it to construct things in space. I know DARPA Nomad, NOM4D, just had a proposal solicitation asking for how do you build very large structures in space from things you mine on the moon. So that's probably the path that's going to be best in the near term. And I think the one caveat to that might be the helium-3 mining is if you can go and get it in enough quantities and they can get fusion to work here on Earth, that would probably be worth bringing back.
Yeah, helium-3 was definitely going to be on my list as well, so thanks for mentioning that. All right, as far as your choice of launch providers, you're going with SpaceX here in 2023. What influenced your decision with them versus ULA, that sort of thing? And do you foresee your company using SpaceX on a consistent basis, or is that going to be pretty much an open bid on every mission?
Portions of that we probably can't answer.
Right.
Our company strategy, but I'll say that SpaceX has been a spectacular partner. We really like that their engineering approach and methodology is very similar to Masten's, and you see that in Starship. Test early, test often, and the proof is in the hardware. So from that perspective, it's been an absolute joy to watch Starship progress, and very exciting that they got the HLS award for Artemis to go to the moon as well. So very, very exciting to see what the next several years are going to bring in this space, and who knows what the future will hold. There's new launchers coming online all the time now with the small satellites, and several of them have plans to make bigger rockets. And I know ULA is bringing Vulcan online, and they're going to be launching Astrobotic soon. It's a very, very exciting time to be in space. I'm so excited what the last several years have done for the industry, and I can't wait to see what the next 10 years brings.
I couldn't agree with you more. Definitely one of the reasons why I started this channel, as a matter of fact, was because of all the private space flight that was getting started. And that is, something that I'd like to ask you about as well. You mentioned company strategy. I know there's a lot of things that you probably can't talk about, but I've seen at least what is ostensibly your main facility, and in Southern California, and I think you've had started with humble beginnings. I think that'd be a pretty accurate statement. Correct me if I'm wrong. Where does Masten go? What is your long-term goals besides what's on the docket right now?
So definitely Masten started in humble beginnings, and I think we've been described as like the scrappy new space company. We are a little bit different than others in that we have been revenue driven for the last 9 years, nearly a decade. So we're living off revenue, and we choose to invest. We choose to invest our income into more technology and pushing these missions forward. Masten invested in the lunar lander for 5 years before Eclipse came along, and so really trying to look ahead and position ourselves for where we think the market is going to be has always been important to us. So where the future holds, that's an excellent question. Beyond the moon, for sure. Going to be going all over the solar system and really focusing on being a reliable transportation and solution partner. So.
Well, you kind of led into my next question, actually, when we're talking about going beyond the moon. Your rover, of course, uses a rocket engine to burrow into the lunar surface. Therefore, I'm assuming using it on an asteroid would probably achieve escape velocity using that same rocket. Do you suppose that a modified version of that rover could be used on an asteroid, perhaps with a way of anchoring it to the surface or something along those lines, or do you think an entirely different technology needs to be used on asteroids?
Definitely. I did see your video about Phobos. Very, very fascinating. There are solutions that let you anchor it down. It takes more time and complexity, but it is very, very doable. And you're exactly right. You don't want to be launching your spacecraft off of the body that you're trying, and that tends to be counterproductive. So yeah, there's solutions there. The biggest challenge is keeping we use the rocket engine gas pressure. So after it excavates the crater, we use that gas pressure to move the freed up regolith and ice and minerals down through the system. So it is a very, very large pressure gradient, and so we can't have that pressure escaping from underneath the dome. So that seal between the surface and the dome to keep the pressure contained has been it's one of the harder engineering challenges on the system. So that'll extend itself throughout the solar system.
One thing that's, let's assume that you just mentioned Phobos, and if anybody who's gone through, well, I have a pretty big catalog of videos, but I've mentioned using the moons of Mars, as resources for our exploration of it. Of course, we don't know a lot about these moons, but let's assume that they are similar to C-class asteroids and have a lot of carbon, have a lot of water. Do you think that utilizing these moons as fuel depots, that sort of thing, do you think that that's kind of a fundamental part of exploring Mars, or do you think that it's more trouble than it's worth?
I think if you can get there and extract things in a mass competitive manner, that's where the system closes. So you don't want to send a 600-ton mining apparatus to mine 100 tons of fuel. That doesn't close. But if you can send something that's very low mass and efficient, and you have the time to wait for mining, and you can extract and refine what you mine into something usable, then you can build towards that sustainable ecosystem. And certainly Phobos is an interesting choice because it is orbiting Mars, which is very convenient. Some of the other asteroids, the amount of fuel that you spend to get there might be prohibitive versus what you can get out of them. But that's going to be very mission timing and orbital mechanics dependent.
Yeah, and also depending what they're made out of, which we still don't really know. So yeah.
Yeah, if you look at OSIRIS-REx, it seems to be a real bundle of loosely conglomerated, so you can just tap on it and extract things from the surface. But it'll be very interesting to see what those new asteroid missions show us about Psyche and other bodies in the solar system.
Going back to the moon, this is essentially my final question. Your first lunar mission in 2023. This, of course, I'm sure is going to be a very exciting time for you. There are a number of, obviously, you're carrying a number of experiments along on your lander. What are the things that excite you the most about it?
That's a tough question. I'd have to say all of them because they're all very interesting in their own ways. Though some of the ones that are looking at plume surface interactions on landing are of particular interest. We've flown some experiments here in Mojave and had several contracts through the SBIR program looking at plume surface interaction, physics effects, why it happens the way it does, and what controls the scaling. It's incredibly fascinating science, and it's a lot harder than it looks at first pass. XKCD did a great comic in a New York Times article where they compared the physics of sand is harder than quantum mechanics because you have all the complexities of fluid and Navier-Stokes, and then you also have millions to billions of particles that are all unique, and so you've got interesting friction and mass and particles bouncing off each other. It turns into a real computational nightmare that we can't necessarily solve right now, and so we look for approximations and shortcuts and kind of developing the fundamental theory of, okay, as we go and land on the moon, particularly with something the size of Starship,
which is what we're planning to do. That is the choice for the HLS right now. So yeah, I mean that I was gonna go there actually. I mean, how do we land 100 metric ton plus something on the lunar surface without creating a massive debris plume? How do you avoid that?
I think you have to be very careful. And I think some of what we've seen SpaceX do in their renderings, such as moving up the landing thrusters from the base up to kind of the 3/4 of the way up the vehicle, that's going to do a lot to mitigate that damage to the surface. Because if you got a Raptor engine that's firing into the surface, oh boy, man, it's going to kick up so much regolith, and it's going to go into lunar orbit. It's going to reach escape velocity. So there's some serious implications for both astronaut safety and science that have to be solved as we go back with these larger vehicles, and that's what makes it incredibly exciting.
And just for clarification, landing is possible with those hot gas thrusters if that indeed is what they're going to use, but they're probably going to need to use the Raptors to take off, aren't they?
That I'm not sure on. It probably depends on their mass.
Yeah.
So that'll be an interesting thing. But yeah, you will make a very large crater on the moon if you fire a Raptor engine into it. The evolution of these deep cratering, again, check out Phil Metzger on Twitter if you haven't. He has excellent discussion on some of these points. You can get a deep crater that excavates itself to the depth of the plume within 0.3 seconds of engine ignition. So it's an incredibly rapid process, and usually when you do an engine startup on launch, you want to get your engine running, do some health checks, get through that startup transient and make sure it's safe to actually lift off and not abort and recycle. And so the fact that you can't even get through those kind of preliminary checks before excavating a meters deep hole on the lunar surface would be an interesting engineering challenge. So, but I'm sure SpaceX is up to it.
I'm sure they're up to it as well. And just for clarification purposes, also, it is still in the wheelhouse for maybe Blue Origin to get into this as well. And their lander is far from tiny. And I would assume that firing their engine to land is going to create a bit of a debris plume as well, especially since I don't think they have any other alternatives besides using the main engine. So this is a problem for just about any HLS system, not just Starship.
It is. And I think landing pads are going to be the solution, definitely near term and long term as well. I think landing pads will be one of the first pieces of infrastructure that we establish on the moon because they're so important to getting there and returning safely and enabling other infrastructure to be in the area and not get blasted by plume ejecta when a resupply ship lands, for example. You don't want to be peppering your lunar base with 2 to 3 kilometer per second rock particles. So something that should be published fairly soon on NASA NTRS is the results of our NIAC landing pads from last year, and I think there's a ASCE paper about it as well. But that's one of the kind of more advanced projects we've been working on here is how do you bypass having to send a precursor mission to make a landing pad for something like an HLS lander. You can make the landing pad as you're landing, and then you kind of solve your own problem. So that would open up a lot more lunar real estate to repeat missions and keep everybody a lot safer.
Well, I want to thank you very much for everything that you've shared with us today. I wish I could keep talking with you, but unfortunately we have run out of time. So thank you so much for joining us, and I really do wish your company the very best. I think that you are certainly one of the most innovative private space companies out there, and you've got some exciting stuff that you've put out just for public release. I can only imagine what you have going on behind closed doors. So thanks very much.
Thank you so much for talking with us today, and exciting things await. We'll see what the next year or two brings for the moon. It's going to be good times.
No doubt.